So we have, this is a question number 2a. As you can read, by evaluating the gradient at various points or otherwise match each differential equation below with the slope field. And domain, if you see the domain for each one, each figure, there is +4 to -4. It's both horizontally as well as vertically, right? So what I will put here, I will take the values from -4 to +4, right? And here, since this derivative equation is given in the form of x, so I'm writing here this is x values, and in second column gradient, I mean dy over dx, right? Y value is not here like in previous question. So let's we start to find out gradient at each point. So when x equals to -4, so you will put -4 here, so -4 and -2, -6, right? Then -2, -3 and -2, -5, -2 and -2, -4, -1 and -2, -3, 0, -2, -2, 1, -2, -1, 2 -2 is 0, and 3 -2 is 1, 4 -2 is 2. So this is the value of the gradient, right? Now we need to draw this. So this is Cartesian plane, x-axis and y-axis, right? Now, see what is the meaning of this one. If x equals to -4, gradient is -6. You know, so it means what does it mean? It means wherever x is -4, gradient will be -6. Okay, so on all the points where x is -4, gradient will be -6. So you can see x is right. So this x equals to -4, this line, this vertical line, this will be the vertical line where x is -4, right? So like this point here, at this point, so here gradient is -6. So understanding this one, at this point x is -4, so gradient -6, negative we draw like this, right? It's this one, this point also here, -6, negative, right? Here also negative. So all these points, it will be like this. Then when x is -3, look at this vertical line. Here x gradient will be -5. So here negative, tip, negative, 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 negative. Then x equals to -2, right? Gradient will be -4, means here negative -4, negative, 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 negative. Then x equals to -1, this vertical line. Here also -3 means negative, right? Negative, 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 negative. When x equals to then 0, x equals to 0 means y-axis, it's -2, negative. So this negative, 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 negative. And when x equals to 1, it's -1. So x equals to 1 on this one. So negative, 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 negative. X equals to, okay, x equals to 2, gradient is 0. So draw a flat line. This is 2, 2 here, 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 right? This one. And then if 3 is 1, so positive, 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 positive. 4, this is 2. Okay, this is 2, positive, 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 and positive. So this is the slope field. Okay, this is the slope field, and we check which field look like this one in the question. So if you see this field 3, right? This field 3. this field looks like this one, so it is equivalent to this field. Okay, third. So dy over dx equals to x minus 2. This third part, this third field shows this gradient equals to x minus 2. So this way you can draw the gradient for other point as well. So you need to practice each and every part. You may have difficulty in the beginning, so I suggest you can draw this field first, and then you can see whether which field looks like this. Okay. Okay guys, now you can see this question. We have question number 3, right? So one of the following slope field is for the differential equation y dash equals to cos x plus y, and the other is for the differential equation y dash equals to x minus y, cos x minus y. So we have two differential equation field a and b, and we have two equation also, cos x plus y and cos x minus y. We don't know which field for which equation, that we will determine and the solution. Okay, but in first part, if you look at this one, y dash equals to cos x plus y and y dash equals to cos x minus y. Write down the equation of a line along which the slope field would have a gradient of 0. So gradient, what is this? Y dash is what? This is the gradient, right? And what the question is saying, this gradient is 0, right? This gradient is 0. So let's look over this one. We solve this 0 equals to cos x plus y. Okay, or you can write x plus y equals to cos inverse 0. So we have two possibility. This is plus minus, either you go clockwise, then pi by 2, anti-clockwise, minus pi by 2. So it is this, right? So it's pi by 2, maybe plus minus, depends on clock and anti-clockwise. Okay, so y equals to, what is the equation? Y equals to, you can remove this, you can move this x from left hand side, so this becomes plus minus y over 2 minus x. Okay, so this is the equation, this equation from the first derivative. And second, 0 equals to cos x minus y, so it means x minus y equals to cos inverse 0. So x minus y equals to plus minus pi by 2, or you can write plus minus pi by 2 plus x equals to y, or y equals to plus minus pi over 2 plus x. Okay, so we have these two equations. So in first case, we have to write down the equation. Okay, we have got the equation, right? This is the first equation, right? From this we are getting this. And this second equation from this derivative. Okay, now if we look at part B states state which is the slope field. Okay, in part B we have to find out the slope field. So instead of drawing a slope field, I would like to suggest you, since we are allowed to use calculator, right? So I will use calculator to check, because I have the slope field, the thing which I have to determine the slope field for a particular equation. So I will use here calculator over here. So this calculator. So graph. This one is the graph. Okay, so I have already typed the equation. First is pi by 2 minus x, second is pi by 2 plus x. Okay, so you can see this is right. The first, if you have doubt, I will delete this first so that you can. Okay, so if we have this pi by 2 minus x, right? Pi by 2 minus x, then this is the equation. Okay, this is the equation for, you need to note down this one. if you have pi by, you have equation y equals to plus minus pi by 2 minus x, then see this one, then you can type this is pi by 2 plus x, right? Set pi, then come down, this is 2, then this is plus, this is x. Okay, draw. Okay, so red one, right? So if y equals to pi by 2 plus x, then you can see the red line. Okay, see the nature of red line. Then I think it will be easy for us to determine the slope field. Okay, so let's again share this one and this. Okay, now if you look at this one, if you look at this one, uh, a field. Okay, so okay, for cos x plus y, right? For cos x, when we have cos x plus y, so we were getting y equals to plus minus pi by 2 minus x. Okay, so this straight line we find over here in B. You can see in B because it was, look at this one. See, yeah, this is the B. Okay, you can see. I'll show you. So so you can see this type of line. Look at this line. This is the line. Here is a straight line. Okay, right? So for part, this is okay, slope field. So B slope field is suitable for this one. So obviously then you can see this here. So this will for A, right? A. Like, okay, if you start from the zero means y value t. Okay, this is the t size of tumor and this is t. A small t is month. So if t is 0, so wherever t is 0, the gradient dt over dt will be 0. So how to show 0? This flat line. On the horizontal axis, gradient will be 0. So gradient means 0 means this. Straight line, straight flat, or parallel to x-axis. Right? Then 1 is positive value. So it's less than 1 means more inclined to horizontal. This will like this, this positive value. It's positive, right? Positive. And next one is the 0. Again, 0 means this flat line at every point. Then it's negative. Negative means this line. This is the way to show the negative. Okay. So this will be the slope field for this. This is the first point. From first point, the second point. This is the second point, right? We will, okay. From this second point, it's also going up. It's also going up, right? It's going up to here. And from this one, all the points are flat, means horizontal. So it will move like this. The curve will move like this. Okay. So this is the way to draw the slope field. Size of tumor. So you can see our graph is going like this one, but it's not going, it's around 2. So it's like this one. I mean, this one. Okay. Right. So it's approximately 2. You can write approximately 2. Right. Size of tumor. So this will show size of tumor. Size of tumor. So size of tumor means it is approximately 2. Right. You can write it's 2 centimeter, 2 centimeter cube. Obviously, this will be the approximate value. Okay, approximate value. And explain why this model might be suitable for the modeling the growth of the tumor, right? So when we look at this one, this data, on the basis of this data, right, we see here at this point, okay, at the at this point, this line, the slope is going to be consistent, right? This slope, I mean this slope, right? This slope is is consistent. Consistent is like this. Here the line, the gradient is the, this gradient is parallel to x-axis. Parallel to x-axis. It's going parallel to x-axis. So making the gradient 0. So we, in this case we don't see any further increase in the size of, tumor, okay, because this line is going to be um, parallel to axis. So that's why it may be suitable for the, to predict the size of tumor.